Getting into the University of Zimbabwe's top engineering programs used to rely entirely on your final exam scores. But now, there is a new, timed psychological hurdle standing between you and enrollment, a mandatory psychometric test. Looking straight at the official 2025 admission requirements for the Faculty of Science, the mandate is printed right at the top. You can hold straight A's in pure math and physics, but those grades alone will not secure your spot anymore. Standard high school exams give you hours to carefully work through complex equations. These new aptitude tests demand split-second decision-making, giving you a tiny fraction of that time to analyze technical data. Because this testing requirement was rolled out quickly, thousands of prospective students are now scrambling, unsure of what subjects to actually study. The rules of admission have changed. Without a specific strategy for this test format, the clock will likely run out before you finish half the paper. To beat this assessment, we need to look at the specific experiences of the candidates who sat for the test last year. While many university psychometric tests focus on recognizing abstract shapes or verbal logic, the engineering faculty uses a targeted technical question bank. Reports from previous applicants suggest a focus on specific A-level physics topics. One candidate who applied for electrical engineering noted that their assessment centered almost entirely on DC circuits. Our goal now is to build a framework so you can dissect these specific circuit diagrams and solve them under the pressure of a ticking clock. Identifying the subject matter is step 1. Step 2 is practicing the math until the calculation becomes a reflex. Put away generic spatial reasoning workbooks, pull out high school physics notes, and isolate chapters on electricity. This graphic shows the formula you will use most often, Ohm's law. It states that voltage equals current multiplied by resistance. If a test question gives you any two of these numbers, you can find the third by rearranging the equation. Look at this series circuit diagram. Components are placed sequentially, current remains constant, and total resistance is calculated by adding the individual resistors together. But in a parallel configuration, the rules invert. Voltage remains constant across each branch, and total resistance is calculated using fractions. You do not have time to ponder the theory behind these rules during the exam. They must become instantaneous, unthinking responses. The primary challenge of this assessment is the timing required to finish. Standard psychometric exams often present 55 questions in just 14 minutes. That leaves you an average of exactly 15 seconds to process and answer each problem. If you try to write out a multi-step calculation on scratch paper the way you did in high school, you will likely run out of time. To slow you down, examiners may include irrelevant, distracting data, like extra battery loops or decoy resistors, into the diagrams. You must practice the art of skipping. If a diagram takes more than 30 seconds to calculate, make an educated guess, flag it, and move on immediately. This assessment functions as a trap for perfectionists. It measures your ability to manage your time and filter out visual noise, just as strictly as it tests your memory of physics formulas. Here is a mock question. Find the current passing through one resistor in this massive parallel network. The clock starts now. Step 1, identify the target node. Step 2, discard irrelevant loops. Step 3, apply the parallel circuit rule. The 12-volt source carries over exactly. With the voltage and resistor identified, we execute a fast Ohm's law calculation. Current equals voltage divided by resistance. 12 divided by 4 gives us 3 amps, and we lock in the answer. By ignoring the decoy data, a problem built to waste minutes of your time becomes a 10-second mental calculation. This is the entrance to the University of Zimbabwe, the physical campus you want to step onto as an accepted engineering student. Success in this environment depends on integrating your A-level circuit knowledge with the speed required by the testing format. Here is your immediate assignment. Track down 3 past A-level physics exam papers. Comb through the test packets and visually isolate only the questions featuring DC circuit diagrams. Set a digital timer for exactly 15 seconds per problem. Drill these specific questions until the time limit no longer induces panic. The UZ assessment is designed to filter out the unprepared. By drilling this specific system, you turn an unknown threat into a predictable, conquerable process.